Are you ready?
Yeah.
Okay, go ahead.
The beginning I have just talked about, and then we can move on about this process. And first of all, this picture is just like what Kavita showed, but I will answer the question about you guys. First of all, why this from the bottom to the top, the temperature is decreased. It's not just the tower decided. Actually, it's the gas decided. When the furnace heated this compound and it will goes into this tower, and the gas will actually goes to the top of it. So the top of it is have the lowest temperature, and then this temperature will have a level increase from the top to the bottom. So this temperature will decide this is the gas, this is the liquid, and at the bottom to the solid. And for the carbon, numbers of carbons, which decided the boiling point, because when the carbon when the compound have more carbons, the atomic molecular weight will increase, and then the boiling point will goes up. So that's why you have more carbon atoms, you will have higher higher boiling point. And then I will just focus on the details of the process. I said, first of all, I want to explain how these symbols tell us. These gray ones are the container or equipment in the industrial process. And these arrows are the flows of the gas or liquid or solid from one container to another. And the blue ones are the products from these containers. And from the top to the bottom, it also has the temperature levels. From the top, it's has the lowest temperature. First of all, the gas goes into the gas processing, and it is divided into two parts. Fuel gas goes into the amine treating, which will desulfide of the sulfide in this of the hydrogen sulfide in this gas, and give you the refinery fuel and the hydrogen sulfide. The hydrogen sulfide goes into the cloud sulfur plant, which will give you the sulfur. And then the other part goes into the Marox treaters. This is a very important equipment in this process, and you will see a lot of it, a lot of them. This equipment is treated with the mercaptans, which is these kind of things. And then it gives you LPG, which stands for liquid petroleum gas and butanes. Second part is the lighter naphtha and the heavy naphtha. These are very important chemical hydrogen compound, carbohydrate. First, they goes into the hydrogen treater, which will also deal with the sulfur in this gas, or in this liquid, and then it goes two parts different from each other. The first one is the isomerization plant, and this is the electric reformer. This first one goes to isomerate this carbohydrate into linear ones, and this catalytic reformers will give you bigger smaller carbohydrate into bigger ones as alkene, not alkyne, not alkanes. And then these two parts are the fuel and oil goes into the Marox treater and the hydrogen treater, and it will give you jet fuel and kerosene and diesel oil. And the last part of it is in the bottom of the atmosphere distillation tower. This part are actually a lot of residue in it. It will give you the gas oil and goes into the FCC, feed hydrotreater. FCC is short for fluoride catalytic cracker. And this part is also equipment to deal with the sulfur in this residue. And this vacuum distillation is a vacuum atmosphere, not just this atmosphere in the air. So the boiling point of this residue will goes down, so they can be gas or liquids, and then divided from each other. And this oil goes into the FCC cracker, which will give the carbohydrate depart, and then will give you the smaller carbon hydrogen, and it goes into the gasoline blending pool, which is a mixture of all these small carbohydrates. And then the last one are the solid one. And as we all know, the asphalt is one of them, and the petroleum coke. And also part of them will also become liquid and then goes into the gasoline blending pool. So that's the not very detailed, but actually a rather overall refining process of the petroleum. So thank you for your time. And do you have any questions?